Hello there. In this video, we will show you how to design a sample process that includes Excel operations with Robusta RPA step by step. In this automation process, we will open an Excel file and check whether there is any flight routes data in it. If there is, we will add two columns, one for calculating the number of days between departure and return dates, and one for combining these dates. Then, we will continue with a repeating sub-process since we want to perform operations for each row in the Excel file. In this sub-process, we will set the values for the newly added columns. We started our process by using the Open activity under the Excel section to open the Excel file that contains the flight routes data. Just drag and drop the activities you want to use into the design area as I have just shown you and enter the relevant parameters. In the name field, we wrote the Excel name after the default open to explain what is done in this step. When we similarly enter a value in the name field for all the steps, it becomes easier to understand which operations are performed through the process flow. Then, we wrote the directory of our Excel file with its name to the Excel file name field. A reference name is given to the Excel file in the Excel name field in order to choose which Excel file we are processing in the next steps of the process. With Read Excel to Dataset activity, we transferred the data in the Excel file to a dataset. Later, we will modify this dataset and write data back to the Excel file once changes are completed. In the Excel name field, we selected the reference name of the Excel file. We checked the has header box because our data has a header row. By doing so, it will be possible to specify the column header values in the column fields in other activities at which we get or set cell values. If there is no header row in the table, we should not select the has header option, and we should specify which column to be processed in other activities with an index value of 0, 1, 2 or by entering the column header as ABC. Since the name of the sheet that contains our data is routes, we wrote this name in the sheet name field. If we left this field blank, the data on the airports page, which is the first page, would be transferred to the dataset. In the new dataset name field, we gave a name to the dataset we will create. In the next step, we got the row count of the dataset with the getSize activity. After selecting the dataset from the list in the dataset name field, we chose the row option in the size type field because we want the number of rows to be counted. Then, in the result variable name field, we defined the variable that we want to assign the row count value as getSize. Then, based on the variable value from the getSize activity, we ensured that the process terminates if the data is not found. And the process continues if the number of rows is greater than 0. To achieve this, we added an exclusive gateway that allows us to create alternative flows in our process. For each sequence flow outgoing from this gateway we set a condition, and process continues from the sequence flow at which the condition evaluates true or from the sequence flow marked as default if all the conditions evaluate false. At the first sequence flow, our condition checks whether getSize variable value is equal to true, which means there is no flight route data. If this condition is met, the process is completed with an end event. At the second sequence flow, we chose the default flow option and did not set any condition expression. The process will continue from here if the first condition evaluates false, which means there is flight data in the Excel file. In case the flight data exists, we continued our process by adding two columns to the dataset with the add column activity. In this step, after selecting the dataset to add columns, we wrote the column header name in the column name field. When the column index field is left blank, the column is added to the end of the dataset. If an index value is given lower than total column size, all the columns right to newly added column is shifted. Since we want to add the column to the end of the dataset, we left this field blank. In this column, we will set a formula to calculate the number of days between flight departure and return date. In the next step, we added another column to set the combination of these dates. After this step, we included the sub-process activity under the structure section to our process to create a recurring sub-process since we want to process each row in the dataset. As in our main process, we need to create a flow with a definite beginning and end in this sub-process. We need to define how many times this sub-process will be repeated in the cardinality field. If we leave this field blank, the sub-process will run once. If repetition count is get from a variable, we need to write this variable name between curly braces after a $sign. This is the expression syntax that allows us to use any variable in the parameter fields. In case repetition count is a fixed value, we set an integer value in this field. In this example, since we want to repeat sub-process as many times as the number of rows, we wrote the getSize variable in the cardinality field. We chose the value of the multi-instance type field as sequential as we want each operation to be done sequentially in our sub-process loop. When we make these definitions, the loop counter variable is automatically defined at the beginning of the loop. This variable, which first takes the value 0, increases by 1 at each iteration. When the value of the loop counter variable reaches to the cardinality value, the loop is automatically terminated. In the sub-process, we first obtained the flight return date from the dataset with the getAction activity. In this activity, we set the column header that we want to get data from in the column field. Since we want to repeat the same operation for all the rows, we set loop counter variable in the row field. The index value of rows and columns in the dataset starts with 0, same as loop counter variable. Finally, we assigned the value we get to a variable. In next step, we assigned departure date to a variable, similarly as the previous one. Then, we used the setAction activity to set an Excel formula to calculate the difference of the dates we get to the newly created days between column. In this activity, after selecting the dataset, we set the column header in the column field and loop counter variable in the row field. In the value field, we wrote the formula to calculate the difference between the dates by using the equal sign at the beginning. Since the dates we want to process start from the second row of the H and G columns in the table, the row value in the formula should also start from the second row. So, in the formula syntax, we added 2 to the loop counter variable. Thus, our formula will start from H2 minus G2 on the first iteration, and it will be at H3 minus G3 on the second iteration. Finally, we chose the string option in the type field. In this step, we combined the dates and set the value in the newly added column named concatenated dates. Here, we have written the variables that hold the date values in the value field with a hyphen between them. Then we completed the loop activity with the end event, which allow us to end the process flow. We used write dataset to Excel activity after we finished the operations in the sub-process, which allows us to transfer all the data in a dataset to an Excel file. In this activity, after selecting the dataset and the Excel file, we chose the include header option because we want to copy the header information for newly added columns. We saved the Excel file in the output folder with the save and close activity. For this, we entered the directory, file name and extension of where we want to save our file in the Excel file name field. In the action field, we selected the save and close option from the list and completed our process. Now let's run our process by clicking the Run button. Since the activities used in this process completely run at the back end, we do not see any activity on our screen. In the scheduled process pages, we can see our process was completed successfully. You can follow the steps ran in the process and see the detailed information about the variables that was used in the process on this screen. When we look at the final version of our Excel file, you can see the columns we added. We have completed our how-to video. I hope it was useful for you. Hope to see you again.